Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
It's a touchy subject because every however many years, there's a serious discussion in the US about, quote, privatizing air traffic. There are some people in the community that would see the things that we're talking about as sort of the camel's nose under the tent, as a slippery slope to all of a sudden, the FAA Air Traffic Organization is going to be privatized. And if people are coming into the conversation not aware of that background, there's some serious landmines that they can step on.
You've just heard the voice of Brandon Suarez, who works at General Atomics on technologies required for the safe integration of large military unmanned aircraft into the national airspace system. We recorded the conversation in early October 2021, and it was such an interesting discussion that we got carried away, completely lost track of time, and ended up with more than an hour and a half worth of gold. We did our best to edit the podcast down to a reasonable length, but we just didn't want to leave a lot of good content out. That's why this episode is a bit longer than usual. Anyway, what's coming up is a conversation about autonomy, certification, technology and standards, integration of unmanned aircraft into the national airspace system, and a lot more. You'll hear Brandon discuss how the internet approach to product development does not necessarily work in aviation, how autonomy will likely be rolled out in terms of mission sets and types of aircraft, how to build trust in autonomy, and how important it is for new entrants into the world of air mobility to understand the environment they are stepping into. This and much more coming up right after our sponsor message. This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. We're in for a treat today. I'm excited to have Brandon Suarez as our guest today. Brandon is a technical director for the integration of remotely piloted aircraft systems into the civil airspace for General Atomics Aeronautical Systems. For those of you who have not been paying attention for, call it almost 30 years, GAASI is a leader in large drones, especially for the military markets globally. And Brandon leads there a team that's solving the technical and regulatory challenges that are standing in the way of safe and efficient integration of UAS into the civil airspace so that these vehicles can share the sky with all the other airspace participants. Previously at General Atomics, Brandon worked on the technology stack to provide the Predator B, one of those RPAS, with detect and avoid capability. Brandon is also very active on the regulatory and standards development fronts. He is a co-chair of RTCA Special Committee 228, which is tasked with developing technical standards for UAS on the detect and avoid and C2 fronts primarily. He also served as vice chairman of NATO Industrial Advisor Group Study, Group 205, providing industry recommendations to NATO on how to standardize detect and avoid capabilities for militaries around the world. Brandon has both a bachelor and a master's degree in aerospace engineering from MIT, and he's also an instrument-rated private pilot. Brandon, what an amazing experience so far. I feel we could talk for hours. My biggest fear, I think, for today's discussion is just running out of time. So thanks a lot for taking a break from UAS airspace integration to be with us on our show.
Yeah, absolutely. Thanks for having me. It's a real honor to be here and be talking to you today. Definitely looking forward to the conversation.
Awesome. Likewise. A fun fact, one of our previous conversations, Brandon told me that his wife was actually his first passenger after receiving his pilot license. Together with their 4 kids, I think they still frequently go on flight adventures around the country, which is great because when I took my wife up for the first time, she had a terrible experience and I'm still trying to dig myself out of that hole. So well done, Brandon.
Yeah, that's right. That's I joke. That's how I knew she was the one.
So let's jump right into the discussion. Is there anything that very few in the industry agree with you on?
This is an interesting one. I would say that there's a tendency to bring a philosophy from sort of internet startup software space into aviation, which goes something like, if we just collect enough data, we'll be able to do X, Y, and Z, right? Prove something to the regulator, develop some functionality, some capability. And I've found myself oftentimes warning people against that mentality, which sometimes puts me at odds with a lot of, especially new folks in the community. We've been working on the UAS integration into the NAS problem for well over 20 years now as a company, as a community of interest. And we have learned this lesson the hard way of you can't just bring in data to the rest of the community, be it the regulator or the larger stakeholder community. In aviation, you really do at some point have to roll up your sleeves, do the hard work of systems engineering, system design, security design, and go through a really formal process in certification. So yeah, it definitely doesn't always make me the most popular person in the room, but that is one thing that I keep harping on.
That's interesting. And do you think that this phenomenon is because there are a lot of innovators coming from other industries into aerospace, or is it because we're just faced with some unknowns and technical challenges that we just need the data to prove the safety case?
Yeah, I think it's definitely a combination of some different perspectives, which are healthy and good. And actually, there's been many ways that having new voices and new ideas in the community has been great over the last decade or so. I think it's also that we're coming into an ecosystem that is very much centered around human performance, right? Aviation relies very much on a lot of very highly skilled, highly trained, qualified individuals doing a phenomenal job on a day in, day out basis. And so there's a tendency as we bring autonomy into aviation that we try to just pluck those people out and replace automation into exactly what they're doing. And the challenge is that oftentimes defining what that human is doing is actually really hard, and just collecting more data to try to substantiate, that case is just not something that translates well into this space for some reason. I haven't quite figured out why yet.
Let's talk about autonomy. The UAS systems that certainly you work on have a great deal of autonomous capability built into them. Why do we need autonomous aircraft, autonomous UAS in the first place?
Yeah, there's a couple of ways to approach this. In general, aviation is a global good, right? We can, today, after 40, 60, 80 years of evolution, right, we can very quickly and almost seamlessly move people and goods around the world, connecting people, connecting businesses. The reality is that, the last 80 years have been a steady progression towards higher levels of automation. In a lot of ways, the levels of safety that we enjoy today in commercial aviation are attributable to the sort of steady march of increasing the automation on board the aircraft, in the air traffic management system, in the design process even of aircraft and air traffic systems. And so in a lot of ways, when we talk about the new entrants, novel concepts, these new automated autonomous aircraft that folks are coming up with, it's actually, I find, helpful to just talk about it as part of the evolution of aviation. And when we think about how we're going to achieve the next 30 years, 50 years of growth, it's really that evolution that's going to make it possible, right? Higher levels of automation, enabling more efficient use of the aircraft we have, more efficient use of the airspace we have, of the airports that we have, and ultimately being able to spread jet transportation or just transportation in general to more people and more places and more businesses. And ultimately, that's why we need this.
I often hear people make claims that one claim in particular that I'm sort of sensitive to is saying, well, roughly 80% of all accidents are caused by human factors and human error. So let's remove the human out of that equation. And there you go. We have increased safety significantly, which I think is really short-sighted because Yeah, you're just moving people from one place of the system of systems to another, and you're not eliminating the error. To the contrary, you might be opening up new sources of errors that you can't even envision today, and you won't until you start experimenting with the technology.
Absolutely. Yeah, absolutely. I mean, you look back at, I mean, there's so many good examples, but I mean, even you look back at the shuttle program, right, which could have flown itself to orbit and back, and it wasn't the automation that anything that anyone had thought of that ultimately took down Columbia. It was, a situation that, man, who would have ever thought a foam block falling off of the external fuel tank would take down,
Right.
would break the leading edge. Yeah, so I think that I totally agree with you that is. It might sound good in certain audiences, but I don't think that argument withstands the test of time.
Certainly in the military domain, there's a lot of value to take the human out of that situation if you are conducting a dangerous mission or really long endurance flights where you run into physiological limitations of humans.
Yeah.
But how does that map to the civil side, right? Do you envision that we necessarily need pilotless airliners? At what point is the incremental cost greater than the perceived benefit of receiving that one extra seat revenue?
Right. Yeah. I mean, I think it's important to say from the outside of any discussion of autonomy is that not every aircraft, not every application lends itself to high levels of automation. Yeah, there's plenty of aircraft missions that, yeah, you really do want someone on the airplane for mission reasons, or yeah, like you were suggesting, just for cost reasons, right? It may not make sense to replace or to put more technology on the aircraft. I was sort of thinking this weekend, I live here in San Diego. We're pretty close to the coast, and so on the weekend, it's sort of a constant stream of banner tower aircraft going up and down the coast, right? They're just
Right.
chugging along at whatever 50 knots or something, and it's like, man, that would be such a great mission to use an unmanned aircraft for. And then you think about it a little bit more. You're like, okay, well, you got a pilot on board who is really just trying to build hours, probably not getting paid much, unfortunately. You got an airplane that's probably 50, 60 years old, and that's designed for daytime VFR, really not a sophisticated machine. Man, that operation is not high value. It probably would never make sense to put an automation system on board to take the human off of that airplane.
Totally right. Totally right. So, okay, well, help our audience cut through the noise. Why is autonomy and, more specifically, autonomous operations in the national airspace system, why is that such a challenge? Or is it? I mean, doesn't the military already do that all the time?
Yeah, I think the bottom line is that in commercial aviation, product development is hard. There's very high barriers to entry in aviation. You look at it's obviously a capital intensive process, and you ask, why is it such a capital intensive process? The processes involved in certifying products in aviation are tedious in a lot of cases. And that long payback timeline, right? If you've got to spend years developing a product and you're not going to see a return, now you're asking for really quick scale, but that's also hard in aviation, right? Where you're manufacturing really bespoke systems in the end. Aviation doesn't have the scale of the automotive industry or of the consumer electronics industry. And that really pushes those timelines out pretty far and makes it a difficult investment opportunity, if nothing else.
You meet somebody on the street, you're talking about automation with advanced mobility. And they said, what's the real value of automation? And how would you answer that? And then what are we going to see that will be first and easiest to have autonomy, and what will be the most complex and perhaps less value?
Yeah, so I think that the answer will ultimately have to come down to safety. You're going to have to be able, I think we as a community will have to be able to look, average member of the public in the eye and say, this operation that you want to do, you want to go from point A to point B, you want your package to get delivered at this time. That requires us to use the air and to put a vehicle up in the air, to move it very quickly to get somewhere. And that operation just can't be done safely with a human in the loop the way that it's done today. And it's going to be certified, and it's going to meet, high levels of safety and the rigor associated with all of those things. But we've got to bring equipment, hardware, and software to bear on this particular problem. And I think ultimately, if we're going to sort of win the hearts and minds of the public, it's going to end up being a good that comes out of the addition of these aircraft into the airspace, and then the assurance that those particular operations are going to be conducted with the level of safety that, frankly, everyone's come to expect from aviation, right? Which is very high, at least the portion of aviation that the public sees on a daily basis. But I do think I'll kind of tie those last couple of points together to say that unless we really break the process to bring a new product to the market in commercial aviation, and it's going to be capital intensive process. It's going to involve a lot of people and a lot of testing, a lot of development activities. That's going to mean that we will most likely see the first applications in relatively high value mission sets. Airline operations are really high value operations, right? Those are very expensive airplanes that are operating at very high frequencies, high utilizations. And so really those applications may end up being the most prime for these technologies to come in to the commercial ecosystem.
Can you describe the process of baking autonomy into product development?
Sure. I mean, I think the important thing for anyone to remember is aviation is a highly regulated ecosystem. Whether we like it or not, whether we think that's the way it should be or not, it is. And so we're coming into an environment that has a lot of stakeholders, has a lot of sort of guardians, right? People that want the status quo to stay the way it is because they know it, they think they understand it, and it achieves a very high level of performance. And so the aviation ecosystem has put up a lot of processes over the past, let's say, 80 years. When we think about product development, that's going to naturally include system development processes, right? So the standards around how to do system development, system safety, the systems engineering aspects of product development, but also the level of standardization in software development, complex electronic hardware development, and even the development of particular technologies. You look at the amount of standardization around navigation, it's mind-boggling. The level of detail to get to a GPS chip that everyone trusts to navigate an airplane is just incredible. No single company or person developed that on their own. That was an effort of hundreds of companies, hundreds of individuals working for thousands of man years. And the result is a very predictable, very, very reliable product.
Are you talking about generally GPS or more specifically putting that into a certified product?
Yeah, really any of the technologies that we think of, historically, right, communication, navigation, surveillance, we think about, terrain avoidance systems or airborne collision avoidance systems. Those are all things that are highly standardized, and to deviate from those standards really requires an appreciation for the level of effort that went into getting to that point to begin with.
Where are we in terms of converging on a set of standards for autonomous operation of UAS, and what does that translate into timelines?
Yeah, so my opinion, I guess I should have said that in the beginning. These are all my opinions. I don't represent my company at this point, but my opinion is that the technology exists to bring an aircraft with no humans on board to the market, to fly through controlled airspace, to land at big airports, and to act and feel like a conventional aircraft today. I think the challenge is that there's a lot of folks in the community that don't like the technology that enables that right now.
Elaborate, please.
From my perspective, being involved in the RTCA, RTCA is Standards Development Organization. It's been around for a long time, but it's really sort of sweet spot is in the area of these classic aviation technologies that require standards because everyone is going to be interacting with each other. So communication, navigation, surveillance are the classic examples of that. RTCA stood up a committee in 2003 or 2005, I forget, Special Committee 203, and that group, was comprised of a lot of the real visionaries in this community. Got to work on standards for unmanned aircraft systems at the time, and did a ton of work, a ton of foundational work, but we actually ended up as a community deciding that that process was taking too long, ironically.
Hmm.
And Special Committee 228 was stood up in 2013. And the goal of that committee right from the beginning was to develop detailed technical standards called MOPS, minimum operational performance standards, for just two technologies, which are still considered sort of the critical technologies, detect and avoid and command and control data links. Well, those standards were published in 2017. So in 2017, we had detailed technical standards to go build and certify a line of sight data link, which could be networked to enable beyond radio line of sight, beyond visual line of sight operations, and a detect and avoid system based off of TCAS-2 and an air-to-air primary radar that would enable operations up and through and Class A and in and out of busy terminal areas.
And Brandon, this was for large UAS, as you said, transitioning through some controlled airspace on their way to a special purpose airspace or Class A airspace and back, correct?
It's interesting. We never had as a constraint any particular size or I guess size of aircraft would be the right way to say it. So what we really tried to do was think about how do aircraft operate in today's airspace, right? What are the expectations of an aircraft under instrument flight rules? And you think about if a controller calls up an aircraft and says climb to such an altitude, what rate do they actually expect that aircraft to climb at? Turns out we settled on 500 feet per minute. If you're told to go to a new heading, what turn rate is a controller actually expecting that aircraft to make? Standard rate turns are 3 degrees per second, right? So, and then you look at, how much, power does this aircraft need to have, right? How much airspeed does it need to have? Well, those things are sort of, they don't really matter a whole lot. I mean, you have to stay below certain speed limits in Class B airspace and below 10,000 feet. But beyond that, there really aren't a lot of constraints. It turns out that, the biggest constraint is really just carrying all the equipment that you need to be an aircraft in the NAS. You think about having to carry navigation equipment, radios, having to carry around surveillance transponders and adding TCAS in, that's a little bit bigger box. The detect and avoid standards require an air-to-air radar that has to detect aircraft out at 6 miles, 8 miles. So that physics sort of dictate, okay, if I'm gonna send a signal out and receive it back on this kind of small target, that just sort of has implications for the amount of power that needs to be generated on the aircraft, which, just takes me back to the point I was making about not everyone being happy with the particular technologies, because they do place constraints. When you start stacking up all of the expectations of an aircraft in today's NAS, you end up placing, you might call them artificial, but it's sort of constraints based on physics to some extent, which most people in aviation had historically taken for granted, because to get an aircraft up in the air, to get it above 10,000 feet, let's say, you kind of just had to have certain things on board to keep a person comfortable, right? The aircraft had to be so big to carry a certain number of people to make sense to bring to market. And when you remove the people, you sort of remove all those biological constraints, right? And you can do things with aircraft, the size of aircraft, the speed of aircraft, the dynamics of aircraft that you couldn't do when you had to carry 6 people or 20 people or 100 people. So that's really the disconnect. That's the fundamental disconnect, is you remove people from the airplane. You're not limited by the biological constraints of carrying a bunch of people around. And now you can do things with the aircraft that may not be conducive from the perspective of looking and feeling like a normal aircraft in the airspace still.
So let's say we deployed autonomous aircraft, and 10 years later, after it's been initially deployed, what's the value that's going to be recognized as a result of autonomy that most people don't think about today?
Well, I think the big thing is we'll be able to do things with aircraft that we can't do today.
Give an example if you could.
Yeah, one thing that came out in the early days, well, I guess the pandemic has sort of brought to the public sort of forefront conversation, is the vulnerabilities of supply chains based on the fact that there are people involved in those supply chains, right? We use the word supply chain as if there's just these machines sort of moving around a factory or something. In reality, there's people involved in every link of the supply chain, right? And that's very true in aviation as well. If you have an aircraft that is carrying 2 pilots, 4 pilots, whatever, a bunch of people, and you take them from point A to point B with you, now you're constrained by having those people there, needing to get them back, needing to swap out crews, etc. And in the early days of the pandemic, there were stories that came out about FedEx pilots in China being sprayed down with disinfectant. Right? It's kind of crazy stuff. Or even the thought of, wow, if this virus starts to spread and we can't contain we can't contain the spread, how are we going to do things like air traffic control, where people need to be in the same room talking in close proximity with each other? How are you going to have people moving around an airplane? It sort of exposed a lot of those vulnerabilities that we have that we don't think about every day. If you're able to reduce the dependency on people being with the aircraft, being with any physical asset as it does its job, you can decouple the human aspect of the supply chain from the machine aspect of the supply chain. And that your average person may not sort of appreciate that in the end, but they'll get what they need out of that supply chain, whether it's a package or medicine or even being able to travel somewhere.
So I want to go back to how we ultimately get there, and back to the standards development and the regulatory path. If the standards have been developed 4 or 5 years ago, why are we not seeing regulators approve autonomy? Or what's the current position of the regulators in terms of a path to autonomy rulemaking?
I guess I would take the opportunity to say that we are making progress. The community is making progress. For example, we just the company just finished up a round of flight demonstrations out in the UK. We took a prototype article of a new product that we call Sky Guardian, basically an MQ-9 that's been upgraded for certification, so it'll be a certified aircraft. We've integrated a bunch of technologies like detect and avoid, like a flight management system for navigation that enable it to fly through civilian airspace. And then we've been flying that in the US for years, but we finally got an opportunity to take it over to the UK and actually demonstrate a point A to point B flight where NATS, the civilian air traffic controller, was able to basically treat it like any other civilian aircraft. Definitely the hardest part from a technology perspective is the radar surveillance piece. Certainly the air-to-air radar problem is a big challenge. Tracking multiple aircraft with different priorities, different dynamics, while the aircraft is moving, that's a hard problem that up until this point, I would say, has been the purview of nation states. I mean, that's really U.S. Air Force level of involvement and funding to develop those systems. And they've been, the U.S. government has been pretty stingy with those systems. We do not give AESA technology away lightly. That's a really key sort of national capability. So trying to bring that technology into the civilian aviation space was a pretty daunting challenge. My company has developed an air-to-air radar that's specific for the detect and avoid application, but it's a high power system. It's takes a lot of energy. This is going to go back to the physics problem. It takes a lot of energy to detect a human-sized target at 6 miles. So there's definitely a big gap when it comes to getting that technology down to the scale that could fit on even piston-powered type of aircraft, just because you've got to generate a pretty good amount of wattage. When we talk about translating that to the small UAS world, I think ultimately, again, this goes back to coming into an ecosystem, that we're coming into this aviation ecosystem where there's an expectation among a large percentage of the users of the U.S. airspace that they will not have to equip with a transponder, or ADS-B, or any sort of device that would make it easier to detect them. And so we talk about small UAS. I think that one of the biggest challenges right now is how do you provide surveillance of non-cooperative aircraft if you can't do it from the aircraft, then you got to do it from the ground. And that's a big challenge. So we've developed a standard to do that in the terminal area. I think it's sort of easier to think about it around airports or around vertiports, around infrastructure where you've already got power, you've already got data, and you're going to be conducting let's call it high tempo operations. It's much harder to think about that in the context of a rural area that you're only going to visit a couple times, and now you're going to plop down, a big radar to surveil that airspace for what maybe someone might fly through, So that's going to take a real, either it's going to remain just a really big barrier to entry, or it's going to require some fundamentally different thinking on the part of the regulator to solve that problem without applying technology to it.
Do you think that this lack of adequate radar capability at the form factor and cost level that would support the business case and the size of some of these smaller UAS, do you think that this opens up an opportunity for specialized service providers to offer some advanced safety critical, if you can call it that way, traffic information systems so that you complement or replace what you would normally get from onboard sensors with systems on the ground?
Absolutely. Yeah, absolutely. In fact, I'm counting on it.
Right.
I think the community has been, I don't want to say skirting around the issue, but there needs to be a more open conversation about the need for third-party service providers to be able to offer, safety critical services.
And do you see that FAA and air navigation service providers, are they open to the idea of sharing their safety critical data streams and radar feeds to this emerging industry?
I think they're open to it. There's a couple of examples today. You look at third-party providers who develop procedures, right? Navigation procedures like Jeppesen. Or you look at, the best example right now is Aireon providing space-based ADS-B data. Now, the FAA hasn't bought into that yet, but you see other ANSPs, Nav Canada, NATS, and EASA, being fully on board with that. So I think that's definitely the way that it is that things are moving. I also know that as part of the Beyond Visual Line of Sight aviation rulemaking committee that's going on right now, that is a large topic of discussion, is how to enable third-party service providers to provide those safety critical services. But it's all, again, we need to remember that we're coming into a certain environment here. It's a touchy subject because every however many years, there's a serious discussion in the US about, quote, privatizing air traffic. And so there are some people in the community that would see the things that we're talking about as sort of the camel's nose under the tent, as a slippery slope to all of a sudden, the FAA air traffic organization is going to be privatized. So it's not an easy conversation. And if people are coming into the conversation not aware of that background, there's some serious landmines that they can step on.
What's the relationship between autonomy and the privatization of air traffic?
The idea of any service provider, right, be it the FAA, the role that the FAA currently plays, or a third party that could come along in parallel to the FAA to augment the services provided by the FAA in a private way. Really, what you're doing there fundamentally is you're distributing the cost of a particular capability, right? So instead of having to put let's use the non-cooperative detection as an example. Instead of having to put what may be an expensive air-to-air radar on every single aircraft that's going to fly without a pilot on board, if you could distribute that cost and put that capability on the ground and provide that as a service to everyone, it's obviously going to, not obviously, it will most likely be a more efficient way to provide that capability to the entire ecosystem, right? So that's the relationship is, taking, yes, you're going for an autonomous aircraft, for an aircraft that's remotely piloted. You're going to need a certain amount of capability on board just to land safely, right? If you lose all connection to the outside world, that's there's some basic minimum capability that has to be on board the aircraft. But I think what we're going to find is for everything else, you want to take that off the aircraft. You want to put that on the ground, in the cloud, pick your analogy. And you're going to want to try to provide that as a service so the service provider can maximize their reach, and a particular OEM doesn't have to develop X, Y, and Z capabilities.
What are some of the other technology gaps? Where should aspiring entrepreneurs be innovating?
Yeah, I think navigation is an underappreciated problem. Aviation's use of GPS is very different, I would say, from how GPS is used in many other spheres of our life. Aviation's fairly conservative, right? So you have these very high integrity, high certainty applications of GPS. Most people underappreciate that the vertical accuracy of GPS is actually really poor compared to what you would need in order to, avoid obstacles and terrain the way that I think most people would think an aircraft should be able to. So I would say there's a big gap right now in how do we augment, we obviously need GPS, GNSS more broadly. I think we're going to rely on the classic, VOR, DME, ILS infrastructure that exists in the US and most of the developed aviation world. But there's going to be other technologies that need to come alongside those classic capabilities to either augment or operate during situations where those classic capabilities are not available. An unaugmented aviation GNSS receiver or GPS receiver is not going to get you multiple operations onto a rooftop vertiport, for example. It's not going to get your package delivery drone down the city street. It can't do that. Even though we walk around with our cell phones and we think that it's providing a very accurate location based on GPS, there's a lot that we don't see that we don't appreciate about what's going on there. And I'll just go back to, aviation just treats those things very different from other spheres of our life where we're using those technologies.
Let's go to trust and building trust in autonomous systems. How do we do that? How do we get comfortable enough? How do we achieve this behavioral predictability that supports all traditional safety assurance methods and standards that exist in aviation today?
I think to some extent, the community is got a choice ahead of it. There are some people that are going to say, look, everyone, we just need to roll up our sleeves, do the hard work, build in redundancy and independence and design assurance and, just follow the process and, just get on with it. There's a segment of the community that is trying to responsibly rethink the process. The software design process standards are a great example of this. Aviation's relied on DO 178 for, 30, 40 years now. And it's been great for it's produced high quality, high integrity software for aviation, but it doesn't necessarily lend itself to these complex software intensive applications where almost anything on one of these autonomous aircraft is going to be high criticality. Ultimately to build trust, I really don't think that we are going to build trust with just more flying, more time. I'm not sure that mentality works for highly automated or autonomous aircraft. When an accident happens today, it's sort of easy, quote unquote, for the general public to blame the pilot. It's sort of easy to blame the people that are dead after an accident, or at least make themselves sort of feel like they can understand that. I mean, obviously with an autonomous aircraft, there's no one on board. The OEM, the manufacturer, the operator is now squarely in the crosshairs. So, no one can escape from that glare now. And if you build up millions and millions and millions of hours, and then there's an accident, it's going to be extremely easy for everyone to just forget about all those hours. I actually watched all of the testimony that the Boeing executives did in front of Congress last year as part of their oversight investigation into this 737 MAX accidents. And I was really struck by the chief engineer at Boeing, who basically said, look, this was the same system that had over 200 million flight hours that had performed flawlessly for over the life of the fleet, which is an accurate answer, quantifiable. He was almost literally quoting the system safety guidelines. He was using all those same words. And yet, there were however many 40 families sitting behind him, wanting answers for why it had failed in this particular case. So I think it's a different animal, basically. I do think that modeling and simulation, to kind of go back to, okay, I'm an engineer, I can't help it, right? Modeling and simulation does allow for us as manufacturers, as operators, as an industry to produce a really substantial amount of evidence or information that could be publicly consumable, right? That your average member of the public could understand, that would basically show how this autonomous aircraft is going to react in any situation, right? Just pick a situation, Sully landing on the Hudson, Sioux City accident, you've got hydraulic systems failing all over the place, right? The Air France accident over the Atlantic Ocean. I mean, you can just keep throwing things out, and we'll simulate, we'll model everything. And we'll show everyone how this aircraft handles all of the what if scenarios. And I think there's actually more power in that approach and being actually transparent, and basically just putting all the cards out on the table. Here are all the scenarios. Tell us which ones we missed, and we'll go run those as well.
Where are you seeing some of these, quote, mistakes in approaches, if you have some examples of it?
Yeah, I think there's a lot of work around flight planning or strategic deconfliction, trying to ensure that flight plans and trajectories are conflict-free before the aircraft takes off. And there's a place for that, for fleet operators and for highly controlled environments. But I think there's probably too much emphasis being placed in that particular area. And then, I'll just keep going back to communication. Let me use this as an opportunity to basically highlight where I think, Wisk and others like them who are trying to introduce their products at a very high level of automation are going to get right, which is we do in some ways need to change the system to enable autonomous aircraft at a large scale. A set of flight rules that could sit alongside in parallel with the existing instrument flight rules and visual flight rules that would allow the flexibility of VFR, but with the ability to access airspace and airports that today require you to fly under instrument flight rules. So ultimately, I see a change to the NAS on the level. This would be an extremely big change, right? We're talking technology, we're talking standards, service providers, rulemaking, but ultimately that is the level of change that is needed to get to a point where you would see routine commercial operations of autonomous aircraft on a large scale around the U.S.
When we think about the current drone operators, small package delivery or medical deliveries, or the likes of Zipline and Wing and some of the others, a lot of them claim and practice a certain level of automation in their vehicles and operations. What level of autonomy do these operations typically include?
Yeah, I think that's one of the challenges with even actually just talking about autonomy is it's hard to define what we're actually talking about. I think in some ways the automotive industry is illustrative of sort of the pros and cons of trying to simplify the discussion, right? So you had the 5 levels of autonomy in the automotive industry, and that sort of helped people to wrap their head around what was going on. But in reality, for engineers, it's sort of completely irrelevant. It's not even helpful. So every discussion that I've ever had in a serious way about autonomy, we end up sort of coming back to, okay, what functions are we actually talking about here, right? Which I think is what you're asking, basically. You could argue certain functions are already autonomous on airline aircraft, transport category aircraft today, right? I mean, you look at a Cat 3 ILS auto land on a 777. Okay, the pilot is monitoring the system and can intervene, but if the pilot doesn't do anything, the aircraft is going to land and brake itself. And so that's, in a lot of ways, already an autonomous operation. I think what Zipline and Wing are doing is they've obviously automated the majority of the functions on the aircraft. Obviously, things like stability, they had to automate to even get off the ground, right? Navigation, flight planning, I'm sure to some extent, contingency management. I think the hard things to automate, or to certify, are going to end up being the things that we actually rely the most on humans today for, contingency management and emergency management. If you think about it,
where judgment is most needed.
Exactly. And very quick judgment that is actually drawing on all of those years of training, all of that time in the simulator, all the times where they were sort of bored on a flight deck and thinking through what ifs in their head. All of that comes to play in that instant where they have to make a decision. Where do I put the airplane down? Or, do I try to keep going? Those sorts
right. Well, one might argue, you run these neural networks and AI systems through thousands of such edge cases, and ultimately you end up with a pattern of quasi-predictable behavior. Is that not good enough? Is that even the path?
Yeah, I think ultimately when we talk about big airplanes, right, where we're going to certify to, let's just say, like a Part 25 like standard transport category aircraft standard. I think you're going to have to be able to predict what the aircraft is going to do in situations. So you may not be able to predict it in real time, because you may not have all of the information that the aircraft has, but as part of the certification process, in the lab, in the hardware in the loop lab, you're going to have to run that hardware and software through all of those edge cases and predict and demonstrate that it's doing what you predicted it was going to do.
So for all of those entrepreneurs developing autonomous capability, how should they think about certifying an autonomous aircraft? What does that add to their business plans?
Yeah, to me, the big thing is thinking about what's the next best alternative to whatever capability an entrepreneur is working on. The example I always go back to, because I've studied this problem a lot, is pipeline surveillance, which sounds fairly mundane, but it's one of those things you mentioned in the beginning, the sort of classic, the 3Ds, the dull, dirty, dangerous, that the military has historically used for sort of thinking through when it makes sense to bring an unmanned aircraft. And pipeline surveillance is sort of the classic dull emission. However, it's sort of an easy target, let's say, for entrepreneurs to say, wow, I can do that in a much smaller form factor, with electric propulsion and, off the shelf avionics, open source software, all this stuff, which is totally true at a capability level. Challenge is that you're going to be pitching that to a pipeline operator whose minimum requirement from the government is, I don't know exactly, right, but to basically take pictures of the pipeline once a year, twice a year, 4 times a year with a commercial camera from 5,000 feet, right? And I'm going to just assume that every pipeline operator in the United States wants to do that job very safely and wants to do a good job at it, but they don't need to really go beyond that requirement too far. And now if you come with an automated aircraft, now they've got to figure out how the insurance is going to cover that. Can they use that data in the same way they use the 2 guys in the 172 with a Nikon camera? What do they do with all this metadata and all this new data that you're giving them, right? So we sometimes idolize these high-tech solutions to problems when in reality, the customers may not need to bring that much technology to bear. So you really got to think through the next best alternative to whatever you're proposing.
What would be the top 3 points you would make to an airline CEO as it relates to how he or she should be thinking about autonomy in the next 5 to 50 years and the value of autonomy to his or her airline?
I think from an airline operations perspective, so there's 2 ways that value really gets added. One is, I was talking about earlier, decoupling the people in the operation from the aircraft flying around the country or around the world.
Right.
That has big implications both from a scheduling perspective, but also from a utilization perspective, right? So airlines need to think about how they might operate their networks or their aircraft if they weren't constrained by having to match up people and aircraft at every stop in every destination. I think that will open up. Of course, there's a lot of other variables around the actual cargo, timings and or just the other aspects of airline scheduling, maintenance and stuff. But I think that opens up a lot of possibilities. The other big thing to think about is centralizing certain aspects of airline operations brings huge efficiencies of scale, right? So, and they already do this to some extent with things like their dispatchers and their maintenance centers and weather services and all those things. But now if you start to centralize pilot services and you can start to utilize those people, you can start to utilize those people way more effectively than you ever could when they're tied to a particular aircraft and now moving all over the country in real time. And I think that we'll see that open up different network topologies for the airlines. So the big thing in cargo operations right now is thinking through a switch from hub and spoke to point operations, and that may be enabled by these autonomous aircraft coming into the market.
When it comes to overseeing multiple flights, at some point, it becomes too big of an ask, too much and too fast for humans to be able to oversee all of these increasingly autonomous operations in aircraft. Just think about looking at 3 video games at the same time, right?
or 3 WebEx, Zoom calls at the same time.
Right.
There's a lot we've learned from the air traffic control community, right? So, ATC does quite a bit in terms of balancing the sector capacities and the number of people that are managing a particular sector or center. So there are some things we could learn from that. I think ultimately the regulators are going to require the aircraft to be safe from a system safety perspective, even if the humans are taken out of the loop, for larger aircraft. And usually when we talk about that, we mean losing, the C2 link becoming unavailable, a lost link event. So I think we're going to have to show to whatever the safety target is, 10 to the minus 9, 10 to the minus 7, 10 to the minus 3, whatever, that if that link becomes unavailable, the aircraft, it's going to behave in the way that is predictable, that's been pre-coordinated, pre-approved, and the outcome in that case meets the safety levels that are established for the airspace and for the operation.
Do you see differences in how different countries or different regions think about certified autonomy?
Oh, yeah. Yeah, for sure. Yeah, I mean, there's no doubt that different societies have different tolerances for risk. There's been a lot of debate over the pros and cons of a lot of startups these days starting operations overseas, right? So you look at what Zipline has done in Africa, and which is tremendous. I mean, I have a ton of respect for what they've been able to do. I think they've obviously impacted a lot of lives over there in a positive way, and have shown that those operations can be conducted in a safe way. At the same time, it's not to pick on Zipline, but using them as an example of companies that pivot to overseas operations to get up and running. It's not clear to me at all that any of that data, any of those operations are directly usable in the certification process. And maybe
we've seen that happen with military UAS.
Well, I mean, heck, it's like our company, we've got over 7 million flight hours now.
Right.
And frankly, I'm not sure how any of that data is useful in the civilian context for a commercial certification program.
Yeah, but if you're trying to recreate an operational environment that is very, you can take it from Africa and put it into a certain rural, remote area in the U.S. Why would that data not be appreciated enough?
Yeah, so there's two answers to that. One is sort of the nerdy answer, right, which is things like mundane things like configuration management and data collection and storage, and differences in the operational environment, and differences in the software and all this stuff, right? Which is generally the problem in our case, right? Those 7 million flight hours are amassed over 20, 30 different configurations of aircraft, and we don't even have access to a lot of the data because it's held in by the military or it's classified or whatever. On the more societal side, I go back to the general societal acceptance of risk. So it's part of the not in my backyard challenge that we see around aviation today with noise. I fly out of a couple of general aviation airports here in Southern California, and there are people that no matter how much data you show them, they will resist anything going on at the airport, anything having to do with airplanes. They'll just resist it. There's also if an airplane crashes, how do people respond to that, right? Do they think about all of the positive things that aircraft operation provides, or do they just look at the burning remains of an aircraft and think about how dangerous it is and how crazy it is that that's happening in their country? I think there's a deeper societal aspect to that maybe it's generational, maybe it's cultural. I'm not quite sure.
If I am one of those drone service providers, operators that have set up some operation somewhere outside of the U.S., or I'm doing a small pilot in the U.S. and I want to scale that out, if not coming to the regulators with hundreds and thousands of hours showing failure rates, building up the entire safety case, what other things should I be thinking about or doing?
It's pretty tricky because I know that I'm very sympathetic to the fact that the traditional way of doing certification in aviation really just does not apply well to the size and scale of the aircraft that we're generally talking about in the package delivery or consumer drone kind of world. And I share the frustration of many of the, or I guess all of the applicants to the FAA right now, that UAS type certification applicants, when the FAA put out a policy memo a couple of weeks ago, basically decoupling the control station from the aircraft and pulling back all those G1 issue papers, saying that they're going to now only certify the aircraft and do some other operational approval process for the control station. I mean, that's incredibly frustrating. Many of, sort of household names have been working on this for a long time, and they all had their issue papers issued at the same time. There was a big, press release and a lot of fanfare around that. And many people thought, okay, great. They've got their certification basis. Now they're just off and running. Now it's just a race to the finish line. And then a few weeks ago, this policy memo came out where basically the FAA redrew the lines of demarcation basically, and said that we'll give you a type certificate for the aircraft, the thing that's in the air, but for nothing else. Everything else, your data link, your navigation systems, what they call the associated elements, your launch and recovery systems, and your control stations will be approved by flight standards through an operational approval. But they didn't detail out how that would actually be achieved. And so it leaves more questions than answers, basically.
What should entrepreneurs do then? How should they think about this challenge of building up an adequate enough safety case that doesn't just add data?
I would say to an entrepreneur right now, it would not be reasonable to expect to start building aircraft in a garage and go through a type certification process with the FAA to operate that aircraft on a routine basis beyond visual line of sight. We are far away from that point where a new company could just stand up with all of the tools that it needs to make that happen. But at the same time, I know that there are a lot of companies that have really successful businesses around beyond visual line of sight operations. I have a friend who's the CEO of a company called GreenSight out in Massachusetts, and they're doing data collection for agricultural and like golf courses and things like that. They're doing great. They figured out how to do waivers under Part 107, and they're off and running. They've got the right level of ambition on what they're trying to do. They're not trying to fly across the country. They're not trying to fly at 5,000 feet, right? They're trying to stay over a golf course where no one else should be flying, below the tree line, right? You start stacking up all of the constraints to get the business done without opening yourself up to an unattainable level of scrutiny, basically.
What can the civil sector learn from the military on the topic of autonomy?
Yeah, it's a great question. To tie this back to our conversation about acceptance of risk, obviously the military is willing and able to accept risk, not in an irresponsible way. I think that's often a misunderstanding. There's this sense that the military is just out there kind of doing crazy stuff. There's some of that going on, but my observation of how the military is doing this is extremely careful, very responsible, very cognizant of matching the level of risk that they're willing to accept with the operational environment. And I think there's a lot that, the FAA is there. They're before Wes Ryan left the FAA, he was talking in a very profound way about the safety continuum, right? And the expectation of safety that the public has for different aircraft and different operations. And I think, really the military has just embraced that concept. They may not use those words, but you look at the way that they've done airworthiness certification for Gray Eagle, for example. They created a new category in the airworthiness regulations to allow themselves to apply the appropriate level of rigor to that aircraft, which has been a very successful aircraft, very successful system, and everyone recognized from the very beginning, well, there's no human life on board, so let's think about this differently. The other thing, just at a technical level, I guess I would say, is in the autonomy space, is that the military has been willing to take on some of the especially difficult aspects. So the government has actually been developing a suite of algorithms, a suite of software that they then provide as government furnished to OEMs to integrate. So that's actually been a real success for General Atomics in working with AFRL, in that we've flown their autonomy engine on our unmanned aircraft. So that's the government recognizing that, okay, we need to own, and not from an acquisition perspective, but from a sort of liability risk perspective, we need to own the really hard part here. And we need to unburden the manufacturers from doing that. That's been really successful. So if you translate that into the civilian world, again, different words, but same ideas, right? You look at TCAS is a great example, right? TCAS and now with ACAS and ACAS-X, those are government provided algorithms that solve arguably one of the hardest problems of all this, collision avoidance. right? So ACAS XA is for, a direct replacement for TCAS 2 on transport category aircraft. ACAS XU is a system that would meet all the detect and avoid requirements for automated aircraft. ACAS XR is meant for rotorcraft, which is really being aimed now at the urban air mobility community, which I think is a great development over the last year. And ACAS SXU is a variant that's aimed at the small UAS community, looking at integrating into UTM service providers. So that's the FAA stepping up, doing the hard development activity to the level of rigor that they're satisfied with, and then providing that to the community to be an enabler. Right, that's a really good example of that in action.
How far along are they in that effort, specifically for the ACAS SXU?
Yeah, they are about a year away from the standard. So it's in the standard development process. RTCA Special Committee 147 is working on that. They've got a few partners that are deploying the algorithms and testing them, and they're pretty far along.
If you fast forward 5 years and 10 years, what does the industry look like?
Yeah, I think there's going to be a much smaller number of OEMs. I guess consolidation is always easy to predict in the sort of beginning phases of any industry like this, but I think aviation just lends itself naturally to larger OEMs that can scale and bring really mass to the problem. I think that we're going to see a high profile accident. And to go back to our earlier point about societal acceptance of risk, I think that should be okay. I think we shouldn't be scared of that. I mean, we should obviously do everything we can to prevent that. But I think that there are going to be a small number of OEMs that have the momentum, the stability to basically withstand that shock to the system. And that may end up what ends up sort of.
This is in the 5 or the 10-year scale?
Yeah, there's a lot of flight testing going on. I think that's going to be in the 5-year time scale.
What would you, in a minute or so, what would you say are the highlights and the most important points you'd like to get across to somebody?
Yeah, I would say that it's important to remember, realize, incorporate the fact that commercial aviation is a highly regulated, established community with a lot of stakeholders and a lot of people and companies looking to protect the status quo. We have to be a part of the system. We have to understand the system, understand the ecosystem if we're going to change it. And I think ultimately, in order for autonomous aircraft to scale and to really provide the most benefit that I know that they have the potential to provide to the world, we're going to need to responsibly change the system in certain ways to enable that. And I think we got to be eyes wide open about that and do that in a very methodical and a way, frankly, that maintains the extremely high level of safety that everyone's used to today.
I love thinking about the outcomes of what we're trying to bring about. And as we think about autonomy and we think about advanced air mobility, Brandon, what outcomes do you think will be most felt by the lay public?
Yeah, I think overall, I think more people will have access to aviation. I often say that one of the most incredible things about being a general aviation pilot is being able to hop in an airplane and go somewhere, go somewhere that you may not be able to get to or may not be able to easily get to in a car or public transportation or whatever. And ultimately, the more people that have access to that capability, the better off we all are. I had this visual in my mind of your average sort of traveling public looking out their window in their 737 or 777 and seeing an aircraft with no windshield and no windows taxiing right next to or right behind or right in front of their airplane. To me, that's going to be the day that we know we've really arrived.
Brandon, thank you so much for being here with us today and sharing all of that insight. It was a fascinating conversation and would love to have you back on the show at some point.
Yeah, thank you guys. Thank you for your time and for this for these questions. It's really just a lot of fun to be able to unspool, and I look forward to keeping the conversation going.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.